Hello students, after doing salts, their preparations, how to prepare salt by neutralization reaction, and how to know that to which family it is belonging, and how to know that from which acid and which base that salt is made up of, we are proceeding now towards some common and useful salts. Some common and useful salts. We are doing them in detail. So firstly, the most common salt which we are using is common salt, and it is NaCl. Okay students, NaCl, which we call as table salt also. So students, remember that whichever salts we will take, you have to study them under two headings. Firstly, you should know its chemical name and also its common name. So chemical name of this NaCl is sodium chloride, you are knowing it. And the common name is either you can say common salt or it can be table salt. Okay, now we are proceeding how it occur, its occurrence of NaCl. So NaCl is mainly obtained from seawater, and in India seawater is mainly obtained from Mumbai and Chennai. Okay, so how the seawater gives out NaCl? How NaCl is taken out from the seawater? Remember students, shallow ditches meaning कम गहरे गड्ढे, बड़े बड़े, shallow ditches are dug. In that, seawater is filled and it is allowed to evaporate for months. महीनों के लिए छोड़ दिया जाता है. As the water evaporate, leaving behind salt. The salt which is present, which is obtained in these shallow ditches, that is crude form meaning students having lots of impurities, that is further refined and iodine is mixed into it. That's why we call salts as iodized salt. You are knowing it. Why iodide is added? What is the usefulness of that iodine which is present in the salt? That iodine or the iodide ion which are present in the salt prevents from thyroid problems. Okay students, so in this way NaCl is obtained from seawater. As the seawater is allowed to evaporate in the shallow ditches, it gives out extract of salt here. Clear? So in this way salt is prepared. Now students, I am taking that NaCl, it is a common salt. It acts as raw material for many other chemical compounds. It is acting like raw material. Raw material meaning students, it is the starting material for the manufacture of many other useful chemical compounds. So we will take one by one all other chemical compounds which can be produced from this NaCl. So first I am taking in that series is NaOH. NaOH, it is also called caustic soda. Now again we will take both of its name, chemical name and the common name. Chemical name, sodium hydroxide. It is a strong base, students, sodium hydroxide. And what is the common name? Common name is caustic soda. Okay students, caustic soda. Soda word is from sodium. If KOH I am taking, that will be caustic potash. Okay, so here it is NaOH, caustic soda. Is it clear students? Now, how this NaOH, sodium hydroxide or caustic soda, is prepared, how it is manufactured. So, manufacture method is chloralkali method. This is the name of the manufacturing method of NaOH, chloralkali method. And how it is done? It is done by the electrolysis of brine, Brine. What is the meaning of this brine, students? Aqueous NaCl, dilute NaCl, water mixed NaCl. And we know that seawater contains maximum amount of NaCl into it. So seawater we can call brine, or if you take NaCl and add water into it, that is also brine. So aqueous NaCl is called brine solution, brine. So how this NaOH is manufactured? By the electrolysis of brine solution. So here I am telling you that how electrolysis is done. NaCl plus water. This mixture is brine, isn't it? Aqueous NaCl, dilute NaCl is brine. Brine, when undergo electrolysis or when electricity is passed, what happens? We know electrolysis is, I am revising it, students. What is electrolysis? Electrolysis is breaking of any electrolyte into ions when electricity is passed through it. So, electrolyte or the substance is breaking into ions. Here we have taken two substances, two compounds are there, NaCl and H2O. Both of these get ionized. Ionized meaning break into ions when electricity is passed. Firstly, I have taken NaCl will break into Na positive and Cl negative. Similarly, H2O will break into H positive and OH negative. Okay, students. Now, what will happen in the electrolysis, students? Firstly, electrolyte breaks into ions and then the ions move towards opposite electrodes. Opposite electrodes, like positive ion will move towards negative electrode and negative will move towards positive electrode. We are knowing, students, two electrodes are cathode and anode. Cathode is bearing negative charge while anode bears positive charge. So on negative electrode, either H plus or Na positive can move. Students, remember that if more than one positive charge is present, how to decide that which will move towards the electrode? Here, these are electropositive, having positive charge on them. So we are observing the reactivity of these two. And you are knowing, students, that sodium in the reactivity series is placed on the top while hydrogen is below sodium. So whichever is less reactive, it will move first towards the opposite electrode. Hydrogen is bearing positive charge, so definitely it will move towards negative electrode. So H plus requires one electron to get stable. So it will receive one electron from cathode. Cathode is negative because of excess of electrons on it. It is made up of electron. That's why it is negative. So this H plus is receiving one electron from cathode and forms stable H atom. But H atom do not have any identity. It do not exist as H alone. It require one more H so that it can form H2 or the hydrogen gas. So one more H plus will come, because if we are taking sample of H2O, it contains infinite number of water molecules. That means infinite number of H plus and OH negative will be there. So this H, one more H plus will take one electron. It will also form H. Now these two H join together to give hydrogen gas. So hydrogen gas will evolve out at cathode. Okay, students? Now positive anode, positive electrode, that is anode. Again, if you observe here, two negatively charged ions are present. In these two, this OH hydroxide ions are more electronegative. So this is lesser electronegative element. So this Cl negative will move first towards anode. And Cl negative, it is having excess of electron over it. One excess electron is there. And anode is deficient of electron. It requires electron. So the Cl1 negative loses its electron. Minus one electron I have written here. It loses one electron and forms Cl atom. Again, Cl do not have any existence, do not have any identity. So one more Cl negative loses one electron and forms Cl atom. These two Cl atoms combine together to give out Cl2 gas, chlorine gas. So chlorine gas evolves out at anode, while hydrogen gas evolves out at cathode. And if you observe this electrolysis reaction, Na positive is left and OH negative is left in the solution. Cl negative is eliminating as Cl2, H positive eliminating as H2, but Na positive and OH negative are in the solution itself. So they both react together. Na positive and OH negative react together to give NaOH. In this way, caustic soda is prepared. Sodium hydroxide is prepared. If you want to write reaction in combined form, you can write NaCl plus H2O. On passing electric current, electricity, we are getting NaOH, Cl2 and H2. In one step, I have written this equation. Balancing twice of NaCl plus twice of H2O. On passing electricity, we are getting twice of NaOH and Cl2 gas and H2 gas. Okay, so in one step also you can write the preparation of sodium hydroxide. Now, if you have observed, students, that we are getting three products here in whole reaction. What are that three products? One is hydrogen gas, second is chlorine gas, and third, which is the main product, sodium hydroxide. All three products which we are getting in the reaction have important uses. So I am discussing that uses also, students. Firstly, the main product is caustic soda, sodium hydroxide. That's why I am taking its uses first. And what are the uses of this NaOH? Mainly NaOH is used in soap and detergent industries. Whatever soaps we are using, they are all basic. So which base is added in the soaps and detergent industries? That is caustic soda. Okay, students. So one uses in soap and detergent industry. Second use is it is used as a lab reagent. If you go to the chemistry lab, students, you find NaOH bottle in the shelves. So NaOH is a main laboratory reagent also. Okay, in the paper industry also it is used. It is used for non-greasing material. Suppose some greasy surface is there and you want to remove that greasy surface. If you want to remove that grease from that surface, if we apply this NaOH, you are knowing that it is having soapy touch. It is having properties of soap. So soap can also remove oil. So this NaOH can be used for the removal of grease from the surface. So it is non-greasing agent also. Clear? Now the next use I am taking is of chlorine gas. Chlorine gas. I think many of you are knowing that where this chlorine gas is used as a disinfectant, as a germicide. It shows germicidal action. It kills the germs. So it is used as a disinfectant in the swimming pools or in the water park. When you go to water park crescent, you find a particular smell in the pool, in the water. And that smell is of actually bleaching powder. Bleaching powder is also manufactured by the Cl2. Here I have written that manufacture of many important compounds like chlorofluorocarbons, like bleaching powder. Remember, these chlorofluorocarbons are responsible for depleting the ozone layer, students. But these chlorofluorocarbons are used as refrigerants for cooling agents. So, they are having some positive effects as well as many negative effects also. So, manufacture of chlorofluorocarbon is done by chlorine. Bleaching powder manufacture is also done by chlorine. Next is, it can also be used for making many polymers. PVC. Have you heard, students? Polyvinyl chloride. PVC pipes. So, here also chlorine is used for the manufacture of this PVC. So, disinfectants, manufacture of different chlorine containing compounds like chlorofluorocarbons, like bleaching powder, and for the manufacture of polyvinyl chloride, polymers. Now, the next use we will take is of hydrogen. Hydrogen is used for rocket fuel, as a rocket fuel. When liquid hydrogen is mixed with liquid oxygen, it is used as rocket fuel. This hydrogen is also used for making vanaspati ghee by the hydrogenation of unsaturated hydrocarbons. We will study it later. Just you remember that hydrogen is used for making vanaspati ghee, and which is called margarine. Okay. Next is for the manufacture of ammonia, NH3, and in turn ammonia is used for making fertilizers. So we can say this hydrogen is used for making fertilizers also. So for today's student, this much is there. Do it nicely, and if you find any difficulty, you can ask me, and complete your classwork copy, students. Again and again I am asking you to do it. Thank you, students.